Um, Welcome to this series. So we'll be looking at paper 6, alternative to practical Igcse biology, which is also a compulsory paper for both core and extended student. Those who want to take the alternative practical options, and this paper is for February-March 2022, paper 6-2, and this paper is for 1 hour. Please, I need you to subscribe and recommend my channel. So first, let's read through the set of instructions that will be given. So in question 1 here, they said a student investigated the effect. So first we're looking at the effect of surface area on the rate of diffusion. So what you need to understand first here is when you're given what they want to investigate, you should be able to identify your dependent and independent variable. So the independent variable is what you change in the course of the experiment, and in this case the effect of surface area will be our independent variable. So it's the independent variable, while the rate of diffusion will be the dependent variable. So once you see rate here, you know that time is also part of what will be measured. Now, the student prepared different sized block of agar. Now, the blocks of agar had different surface area. So each of the block have different surface area. So if you look at that, is what is about to be changed, what will be changed in the experiment. Now, they say the agar contain universal indicator, which made the agar green in color. Now, the block of agar were put in hydrochloric acid. The universal indicator turned red in the presence of hydrochloric acid. So as the acid diffused into the agar block, the indicator changed from green, which it is originally, to red in color to show that the acid has been able to diffuse through. Now, the time taken for the acid to diffuse to the center of the block was measured. So the time taken for the acid to diffuse to the center of the block was measured. So that is what was measured for our dependent variable, which is, this here, the time taken. Now, we also told that step 1, 10 cm cube of 1 mole per dm cube hydrochloric solution was put into each of 4 test tubes. So you find out that this value here will be a control variable because it's constant throughout the experiment. So it's control variable. Now, step 2, they said the student used a ruler and a knife to measure and cut 4 blocks of agar. So they use a ruler to measure and a knife to cut. Now, agar A, B, C, and D from a large piece of agar. Each block was a different size as shown in figure 1.1. So we have agar block of different size and a white tile here. So on the white tile is important because you'll be able to observe the color change. So now they said agar block A was placed into one of the test tubes containing hydrochloric acid. Now a stop clock was started and the color of the agar in block A was observed. The time taken for agar block A to change color from green to red completely was measured, and this was repeated for the other 3 blocks of agar. Now the first thing here is we're told that figure 1.2 shows the time taken for each agar block to become completely red. And they want us to prepare a table to convey this particular information. And they say prepare a table to record the result and convert the time to seconds. So we need to convert this time here to seconds. So let's see how it will look like. So if you want to construct a table, so first this table just have 2 columns. First I have my test tube and I have 4, which is A, B, C, and test tube D, and test tube D. So now I need to also include my time taken in They want it to be in seconds. So for A, B, C, and D, so A, B, C, and D. So that's now for A is 6 minutes 56 seconds. So how will you convert 6 minutes? So 6 minutes will be 6 times 60, whatever you get, 6 times 60 plus 56. If you do that, you get 416. You do the same thing here, but in this case it will be 3 times 60. You are converting plus 2 because you have 2 seconds there. And once you do that, you have 182 for B. This will be 60 times 1 plus 54, and that will give you 114. Then this will be the same 60 times 1 plus 24, and that will give you okay, sorry, this is plus 54, not 14, plus 24, that will give you 84. Now this table alone is 4 marks. Now there's a stated conclusion for the result of this investigation. So go back to this table. You find out that A is the largest and D is the smallest. So if you look at this based on their size and look at the rate at which the time it takes to change color. So simple, you find out that the smaller the surface area, the faster the rate of diffusion. The smaller the surface area, the faster the rate of diffusion. That's all. Now state the variable that the student measured. That's the dependent variable. It's simple. Now if you go back here, you see it here. I said what they measured in this practical was where is it? I think I underline it. Stop clock. The time taken for block. No. Okay, this was what was measured. The time taken for the acid to diffuse to the center of the block. So the time taken for each of the cube to change color. So that is my dependent variable. So is the time taken for the acid to diffuse through the block. So let me use the word that was used, through the cube. Diffuse through the cube. Let me see. Through the cube. I don't feel we should end here. Through the cube, I want to include the color through the cube, and or you can put the time taken to observe color change in the cube. Okay, that will also go. The time taken to observe color change in the cube. That's all. Now there's a steady variable the student changed. That's the independent variable. What was changed in the course of this experiment? So from your question alone, you can see it here. Sorry, if you look at this, they said the effect of the surface area. So what was changed was the surface area of the individual cubes. So what was changed is the surface area of agar cube. That's all. Now, state two variables that were kept constant. I think I also underlined that. So the volume of hydrochloric acid and the concentration of hydrochloric acid, and the same type of indicator was used throughout. So those were kept constant. So you can write same indicator, volume of hydrochloric acid, and also the concentration of hydrochloric acid. Now, suggest one way of improving the method used in this investigation. Simple. This is quite straightforward. Just repeat the experiment and calculate average. Now, describe how step 2 could be carried out safely. What is step 2? Step 2. Okay, the student used a ruler and a knife to measure and cut. So this is a hazard. Using a ruler and a knife to just cut. So how you can do that safely is you can use you cut the cubes on flat boards. So cut cubes on flat boards, so you won't have to injure your hands. Simple. There's no need to put an S there. Now, there's a table 1.1 shows the surface area and volume of the block of agar that were used in the investigation. So we have different blocks of agar, surface area and volume. So surface area to volume ratio, we need us to calculate that. So quickly, let's say calculate the surface area to volume ratio of this here, which is not included. So for you to do that, the surface area is 2.50. The volume is surface area is 0.250. So if you divide it, you have 10:1. So that'll be 10:1. So you can. That's it. Now, C part. Because many organisms have adaptation that increase the area of their gas exchange surfaces. And figure 1.3 is a photo micrograph of parts of a fish gill. So first, let's say you should draw a large diagram. Now, for you to get full mark when drawing, you should make sure there is no shading, no shading. Another one, your lines should be clear lines. You should also have no broken lines. And lastly is your diagram should be large. So if you have this, and this is what I want us to draw, so in this case, make sure I cover more than half the space provided to you, makes it large. So to draw this, you don't need any shading, you just need as much detail as possible. This might not be clear because I'm using a writing pad. I'm not really good with it, I'm still practicing, but no problem. Let's see. First, this part, if you can start from anywhere though. So if I have now, that is a total error. So if you have so no shading was done. I'm not shading anything. So you find out that as it moves up, it becomes thinner. So you can actually count to know how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I already have 1, 2, 3, 6, 7, 8, 9. Can decide to stop there. And this part is a little bit large, so have so if you look at this, it's just so drawing something like this is very okay. Now they said measure the length of line PQ. I don't have a ruler here, so you can just use your ruler and measure this line PQ, and always measure it in millimeters. So if you say, let's just assume we measure this line and we have something like 13 centimeters. What you do, you multiply by 10, which will now give you 130 millimeters. So if I say my line PQ is 130 millimeters, so you just write 130 here. Please try and remember, because the unit is stated here. Now they say calculate the actual length of the part of the fish gill using the formula. Now you have magnification is equals to length this. So what is the magnification is given to you is here is 550. So all you need to do is you come back, magnification is 550. 550 is equal to line PQ, which will make to be 130, divide by our actual length. You can say X. This will now give you, if you cross multiply, it will give you 550x is equal to 130. So divide both sides by 550. So our X actual size will be 130 divided by 550. Once you do that, you get your answer. So I'm not writing anything here because I'm not sure if it is 130, but if you measure it, you should be able to get and follow through that process. Now, fish is a source of protein in the diet. So state how you could test a sample of food to show that it contains protein. Include result positive test. This is for test for protein. You use burette. Use a burette reagent. So a positive test will change color from blue to purple. Positive test will change color from blue to purple. Now, question E is, they said a photographic film consists of a plastic sheet coated in crystals. The crystals are fixed to the plastic sheet by gelatin, which is made of protein. If the gelatin is digested by protease enzyme, the crystal fall off and the film will become transparent, as shown in figure 4.1. Now we have them. Then now the next question is, so before protease treatment and after protease treatment, so plan an investigation to determine the effect. So the effect of temperature, this is now my independent. So that is what I will change on the activity of protease enzyme. On the activity of protease enzyme. So activity of protease enzyme, that is my dependent, what I'm going to measure. Now this is a 6-mark question, and the best way you answer this question is first, you can state it. First, identify your independent variable. So the independent, how you manipulate it is first you use 3 different temperature. Use 3 different temperature, and you should always state it. Use 3 different temperatures. State the temperature. Thus, use 3 different temperature. In this case, you can say 20, 30, 20 degrees Celsius, 30 degrees Celsius, and 40 degrees Celsius. Then you use, how will you keep it constant? Use a thermostatically controlled water bath. Thermostatically controlled water bath. Controlled water bath to keep it constant. And the next thing is what I will measure, which is my dependent variable in this case. So dependent variable is that you measure the time taken for the crystal to fall off the film. Measure the time taken for the crystal to fall off the film, and time taken for it to become transparent. Time taken for it to become transparent. To become transparent using a stopwatch. Now, after you've done that, the next thing when planning, you should look at your control. So my control variable will be the same volume. Can use same volume of protease enzyme. You can even state the volume, let's say 5 cm cube protease enzyme, and can say same volume and also same concentration. Same concentration of protease enzyme. Then you should also look at reliability. You repeat the experiment and take the average. And lastly, you should look at safety. Make sure you use your goggles. Use goggles, wear gloves, because you are working with a high temperature. That's all. You get your 6 mark. Now, question 2. They say cabbage leaves contain vitamin C. They say boiling the cabbage in water reduces the vitamin C content of the leaf. So boiling it reduces the vitamin C content of the leaf. Now, some students investigated the effect of boiling time on the concentration of vitamin C remaining in the cabbage leaves. So they say the student prepared the cabbage sample using this method. So the sample, how they prepare the cabbage sample is first heat a large volume of water until it begins to boil. Then measure the mass. So they measure the mass of chopped cabbage leaves and place the chopped cabbage leaf into the boiling water and continue to boil the water. Remove a sample of cabbage leaves from the water at each time interval. Now state 2 pieces of apparatus other than safety equipment that will be required to carry out this investigation. Now, because they measure the mass, they will need a balance, which will give them the mass, and they made use of heat. They heat the water so they can need a bouncing burner. Now, the vitamin C concentration of each cabbage leaf sample was then determined, the concentration. So the result is shown below: boiling time, vitamin C concentration. So from here you can find out that the higher the boiling time, the less vitamin C concentration. So the higher the boiling, let me use this for higher, the higher the boiling time, the lower the concentration of vitamin C. So next is plot a line graph on the grid of the data in table 2.1. So first, you need, once given a table like this, you need to identify which will be on your x and which will be on your y axis. So usually this is always your x, the first one, and the last will be your y, because this is your independent variable. This is what you change. So your independent variable is your x and your dependent variable is always on your y. So all you need to do first to get your first mark is label your axis. So label your x axis. So this is my x axis, which will now be the boiling time per minute. Boiling time per minute. Make sure you include everything that is there. And my y-axis is vitamin C concentration. Vitamin C concentration. Vitamin C concentration per milligram per 100 gram of cabbage leaf. Of cabbage leaves. So so you just copy everything that is here, indicate it. Now, once you've been able to label your axis, the next thing is for you to put in the values there. So for our x-axis, find out that our minimum value is 5, our maximum value is 25, and your graph should always cover more than half the graph sheet that is given to you. So that's for my x. Let me look at it again. X, okay, 0 to 25. So you can decide to start from 0. Then for every 10, let me see how to be very fast with it. So for every 10, I'll make it so this should be 5. This 10, yeah, 5. The next 10, I can't really see it clearly. Yeah. Well, let me just give very rough stuff. You can always have time to do it. 10, 15, 20, 25, then you can have 30 thereabout. But for my y-axis, I have 13 to 34. That's the minimum value there is 13 and the maximum value is 34. So I can decide to make each, since it's 34, if I make each here to be every 10 also, this is 10, 20, 30 to be too small. So if I make each 5, 10, 15, 20, 25. So if I have 25, I have 30, I have 35. So let me see if the value there is 34, so it falls within the range. So 5, 5. So the next thing is just to plot your data. So at zero, my data was 34. So at 0 is 34, so plus or minus half. So if this is 30, first 5, 34, so this will be 31, 32, 33. I think I didn't even do it properly, but I know 34 will be here for 0. Then for 5 is 31. So 5 is 30, 31. Then my 10, 5 is 31, 10 is 26. 10 is 20, 25, 5, 26. Then 15 is 22, so at 15 I have 20, 21, 22. Then at 25, there is no value for 20. At 25 is 13. At 25, I have 10, 11, 12, 13. Thereabout. So all I need to do is draw a straight line, a line graph. So since it's a line graph, it's simple. Now, if assuming it's plotted properly, I think it should give you a straight line. Then the next, that's all. I've gotten my 4 marks. Then they say use your graph to estimate the concentration of vitamin C in the sample of cabbage leaves boiled for 20 minutes. So all you need to do is you take this value for 20 minutes using your graph, you trace it to where it meets the line. So if you trace it up, find out that it meets it here, then you bring it forward to this point and you take your value. That's all. So 15, this is 16, 17, so you can bring in 17.5. That's all. And lastly, make sure you indicate to get your full mark. Lastly, it is table 2.1. So table 2.1 shows that at the start of the investigation, 100 gram of unboiled cabbage leaves contain 34 milligram of vitamin C. Using the information in table 2.1, calculate the percentage decrease in the vitamin C content of 100 gram of cabbage leaves after boiling for 25 minutes. Vitamin C content at 100 gram after boiling for 25 minutes. So first, what is the formula for calculating percentage decrease? Percentage decrease is equal to your starting value is the starting value. Okay, let me just, it's equal to your starting value minus your final value divided by the starting value So in this case, if you go back to your table, you find out that our starting value is 34, our final value is 13 for 100 gram at 25. So starting value was 34 minus 13, which is our end value, divided by 34. Now if you do that maths well, you have 62%. Now lastly, they said the student wanted to know if the vitamin C has moved from the cabbage leaf into the water that the leaf were boiled in. Now state how the student could test the water for the presence of vitamin C. Now for vitamin C, you add drops of DCPIP solution. Now the positive test will become colorless. So that's it, but let me just give you guys some quick clue. If you want to calculate percentage change is equal to final minus initial divide by initial times 100. Now this is percentage change is the same thing when you calculate percentage increase. Percentage and percentage increase is the same thing, but when you want to calculate percentage decrease, it is equal to your starting value minus your final value, like I've stated earlier while calculating, divide by your starting value times 100. So thank you guys so much, and please I need you to subscribe to Study with Mr. Matthew for constant update